And so I lead us in short prayers and start our lesson.
Okay. Shall I pray in the name of the Father, and of the Son, and of the Holy Spirit?
Amen.
Amen.
Our Father who art in heaven, hallowed be thy name. Thy kingdom come. Thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses,
as we forgive
as
those
we
who
forgive
trespass
those who
against us.
trespass against us. And lead us not into temptation, but deliver us from evil. In the name of the Father, the Son, and of the Holy Spirit.
Amen. Okay, Angela. Okay. Thank you so much. Thank you. So, members, where did we stop the other time? On Friday? I mean, was it Friday or Wednesday? It was on Wednesday. Where did we stop last Wednesday? Last week? For mathematics. And this one you have reminded me again. I've seen work for only a few people. I don't know the rest what they are doing. I've seen the work for for Alexandra. I've seen the work for Lynette. I've seen work for Bazara. I've seen work for Uday. The rest I don't know. Maya, I've not seen your work. Beatrice, I've seen your work. Beatrice, I've not seen your work, please. For Patricia, I've not seen your work for indices. I did not see your work for indices. Ready for you, I've never submitted any work. You submitted a very long time ago when we were still looking at vectors. Please, let's submit our work, okay?
Okay.
Remember, yes, whenever I give work, please, let's submit them. All right?
Yes.
All right.
Yes. Let me hope this is my last warning.
Yes, sir.
Huh?
For me, I don't get.
Yes, forgive us.
I
Get the work sometimes.
which means you did not attend the lesson. How come that you attend the lesson and you fail to get work? That is a funny excuse. That's an excuse, please. Okay?
Teacher.
Yes.
Teacher.
Yes.
Teacher.
Yes, I'm getting you. All right. I was not getting what you were saying. So last week we were looking at indices. And we discussed the fundamental laws of indices, but we listed them, very many of them, but we didn't discuss all of them at length. Now today I want us to summarize indices, then we move to SAGs. So we are left with the two main chapters. So that we move to SAGs. So let's look at negative indices. Negative indices. Let me hope you're able to see what I'm writing, please.
Yes.
Yes.
You're able to see the notes, not so?
Teachers.
All right. So we are saying, I remember we said when we are one of the laws, when we are talking about indices, we said if I have 1 out of A is the same as 1 to the power negative what? 1. But that one can also summarize, like for example, I have 1 over A to the power n. So the power in this case is n. So this one we can write as A to the power negative what? Negative n. You remember that, right?
Yes.
Yes. So where does this law is very important, it's going to help us. At the other time we have looked at that. I don't want to repeat on that. You remember that, right?
Yes.
I don't want to repeat that again. Now let's go to and look at fractional indices. Fractional or rational indices. Rational. When we talk of rational, we are meaning fractions. Fraction can be in the form of A over B. This one is what we call rational or fraction. Okay, anything in fractional form is called rational. So we want to see how does this laws of indices is applicable or is applied in dealing with fractions. Dealing with fractions. If you remember, we said if I have a over b to the power n, we are going to use the property which is called the distributive property. So where this power is going to be distributed for a and b. So this power will become a to the power n divided by b to the power n. So we distribute the powers. Okay, that's how we deal with it in fractions. Are you together, members? Are we together?
Yes, teacher.
Yes.
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 Yeah, good. So when we go ahead, we also went ahead and look at when a number is raised to another power, what do we do to the powers? What do we do to the powers? We also said if I have a to the power n, again raised to the power n. So this one we are going to say a, we multiply the what? We multiply the powers. Now this time we want to look at what if this power, if m is a fraction. If m is a what? Is a fraction. How do we deal with it? Take for example, I have a to the power I have. Again, multiplied by maybe n is 2. So in this case, it implies now where our m is a half and n is what? 2. So following this law, the power law, we call it the power. This one is called the power law. So we multiply the powers. We multiply the power. So which means this one becomes a to the power half times what?
2.
Times the 2. We find that this 2 will go away with this 2, right? Then we remain with a to the power 1. But any number raised to the power 1 is that number. So which means a to the power 1 becomes a. Have you seen that?
Yes, teacher.
Yes. Now, there are times they don't write it to the power half. So that one is what we call the square root or the square law. The square root. How do we deal with square roots? When we talk of a square root is when a given number is raised to a power of a half. Are together? That's why a square root. And we write it is represented like this. That is a square root. This one is it? This one is square root. But if I write like this, I put 3 there. This one becomes cube root. If I write like this, again I put 4 there. This one becomes fourth
root.
The fourth root. But if I write it to like this, I then again put n, which means to n the power, not so. Then this one we call it the nth
root.
The nth what? The nth root. Okay. Are you together?
Yes.
Yes. Now, if I have, let's for example, I have root of a. Okay. I have root of what? A. Then is again raised to another power m. I think that.
Yes.
So applying this one, we know that square root is the same as I have. So which means I can write this one as a to the power I have. Then to the power what? M. Have you seen that? Have you seen that?
Yes.
So using the power law, which means we are going to multiply the powers. So if we multiply the powers, I'll have a to the power half times what? M, which will give us a to the power m over what? M over
2.
M over 2. Have you seen that?
Yes.
So in general, suppose I have the n root. This time I have the n root of a raised to the power m. The n root of m raised to the power m. How do we write that? So this one becomes a n root is the same as 1 out of what? 1 out of n. The same as 1 out of n to the power n. So when we multiply the powers, so this one will give us a to the power m over what?
M out of N.
M out of n. So this one is also very important. You have to take note of that. Okay?
Yes.
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 So coming back here to the square root. Square root, because is written as that, so this one is represented as a half. Then cube root is represented as a third. Then fourth root is presented as a what? A quarter. Then n root is presented as 1 out of
N.
1 out of
N.
n. So we can go on and on and on. Are you together?
Yes.
So for example, if I write 3 to the power 3 over 2, who can write for me this one in this form? Because what I've written here is in this form, right? Not so. Can you break it and write it for me in this form? So for you to write that in that form, we are going to say, this one is going to be the same as, remember this one is a fraction, okay? Is a what? Is a fraction. So we are going to say 3. So what I'm going to do, I'm going to split this 3 away from that, which is going to give me a half times 3. Have I changed? Have I changed, members? If I write like that, have I changed the meaning? I haven't changed, right?
No.
Now, when you see this one is raised to the power half. When it's raised to the power half, that means is a what? Is a square? Is a square root, not so? So which means I can write it as the square root of 3, then raised to the power. Have you seen that?
Yes.
That's how we split it. So you must be in position, you must know how to split when it's given in that form. So now I've given the general form. Can we simplify it? Let's go to this question there. Are you able to see the work on the screen?
Yes.
The question there, the question which is there. Question is saying simplify a 36 to the power a half using indices. So what are we going to do? So I said you first break the 36, the number which is the base. The base is very big. Can you simplify that base to the lowest base possible? So how do we do that? By decomposing. By what? Decomposing. So you find that when 36, then you come and say here, but 36 is the same as 6 what? Squared. Not so. Okay?
Yes. Yes.
So when that is true, which means I'll have 36 to the power a half is going to be equals to the power 2, then raised to the power a half. Okay? So when you take the power inside, when you multiply the power, so we shall have 6 to the power 2 times what? A half. Which will give us what? This one natural death, then we remain with 6 to the power 1.
1.
And 6 to the power 1 is what?
6.
6.
Can you do for me the same? Do for me again for B. Let's look at B. B, we have 64 to the power a third. 64 to the power a third. And this question can be written as, this one is the same as the cube root. Instead, they're asking us to find the cube root. Without using calculator, how do you find the cube root? Using indices. How do you find the cube root? This question can be written like that. Are you together, members?
Yes.
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 So now, if you break, what is 64? 64 is the same as, in the lowest power possible, is the same as?
8
2.
Huh?
2.
Is the same as?
8 power 2.
8 to the power 6.
Is the same as 8 squared, not so?
Yes.
If it is same as 8 squared, this one is the same as 8 squared, or someone can put it the same as 2 to the power
2 to the power
2.
6.
2 to the power 6, or someone can put it 4 to the power. Have you seen that? Have you seen that? So those are the possible ways. But now remember, we are dealing with cube. We are dealing with what? Cube. So we want to find a number that will make this outside to cancel out. And which number is that? Is this 4, right? Not so. So we are going to say
Yes.
taking 64 to be equals to 4 to the power. It's because I want to find a way of eliminating this outside. Okay? So which means I must allow 4 to the power 3 to the power outside. Have you seen that? Equals to 4 to the power 3 times outside. You find this and this will cancel that. Then we remain with
4
4
to the power
to the power 1, which is what?
4.
Which is 4. Someone may ask, is it wrong that if I use 2 to the power 6, does it give me a different answer? No, it will give you the same answer. Are you together?
Yes.
But you cannot use this one. You cannot use 8 to the power 6. I mean 8 to the power 2. Why? Because this number is not divisible by 3. Are you seeing that?
Yes.
So we can use 2 to the power 6. It must give us the same answer. You can say also, alternatively, you can say 64 is the same as 2 to the power 6, which will give us 2 to the power 6 to the power outside. Okay? Which will give us 2 to the power 6 times outside. By 3, 1. By 3, 2, right?
2.
So we find that we remain with
2 to the power 2.
we remain with 2 to the power
2 squared.
2 squared, which is what? What is 2 squared? Is what?
4.
4. You find that the answer is what? Still what? The same. Are you together? You do for me
Yes.
part C. Do for me part C. Do for me part C. What do you get?
Equal 8.
They ask me what is the cube root of 125? The cube root of 125. What is the cube root of 125? What is the answer? Using indices. Using indices. Please use indices, okay? Using indices. Who has finished that? Yes? Yes? The answer is what?
5.
Who can take me through that? How did you get 5? I just want to confirm how you got 5. Who can take me through the steps? You're going to say 125.
125.
It's the same as 5 to 3.
It's the same as 5 to the power 3.
3.
Then you put 5 to the power 3 to the power outside. Not so? Then you multiply the what? You multiply the power. So 5 to the power 3 times outside, which will give us 5. Like that. Okay? Then let's also look at D. We have 8 over 27 to the power outside. To the power outside. Now this one we are dealing with fractions. We are dealing with what? Fractions. So which means it's the same as like when you are saying recall from this one, where we said if I have A over B to the power n, the power is going to be distributed for all of them, which is going to give us A to the power n over B to the power n. You remember that? You remember that, right?
Yes.
So we know that 8 is the same as 2 to the power
3.
Then 27 is the same as 3 to the power
3 to the power 3.
So now we shall say it implies that 8 out of 27 to the power outside is equal to is equals to 2 to the power 3 divided by 3 to the power 3. Then what? To the power a third. Then we distribute the powers. Then we distribute the what? The powers.
The powers.
So this one becomes 2 to the power 3 times a third over 3 to the power 3 times what? A third. Have you seen that?
Yes.
This and this will cancel that. This 3 will cancel the other 3. Then we remain with 2 to the power 1 divided by 3 to the power 1.
1.
Is there anything else we can do there? Remember, they have different base. They have different what?
Yes.
Base. So this one will give us just 2 over what? Over 3. Our answer is 2 over
3.
We can't simplify further because they have different base, though they have the same power. Right together?
Yes, teacher.
Yes. Then another thing you must also, let's look at also this one. Let's look at this one. What we call the receptacles, okay? Okay? Okay?
Yes. Yes.
If I have A over B to the power n, okay? Okay?
Okay.
If I get the reciprocal of A and B, the power will change. The power will what?
Change.
Will change. How will the power change? So in this case, we shall have, now the reciprocal of A over B is what? Is B over A.
A.
Not so.
Over A.
Now the power will become negative. It will become negative power n.
How?
Okay?
Yes, teacher.
Yes. That's another law we have to look at. That's another one important law in mathematics. It's like when we say if I have 1 out of 2, okay? We say it's 2 to the power negative.
1.
How did that one come about? Is by getting the reciprocal of this, okay? Because when you get the reciprocal of this, what is the reciprocal of this? Is 2, not so?
Yes.
So that's why you find that we have negative 1 there. So 1 out of 2 is the same as 2 to the power negative 1 by getting the reciprocals, okay?
Yes.
Yes. So how does that law apply? Take for example, let's look at this question. Simplify 8 over 27. This time I have negative a third. Okay? Have you seen that?
Yes, teacher.
This time the power is negative. But if I want to remove this negative, I must just get the reciprocal of the numbers of the rational numbers. Right together. That's how you remove the negative. That's how you remove the negative power. So which means for us to solve this, we have already seen that 8 is the same as 2 to the power 3. Then we have seen that 27 is the same as 3 what? 2. Okay? So we shall have 8 over 27 to the power negative a third, to the power negative a third is equals to 2 to the power 3 divided by 3 to the power 3 raised to power negative a third. Now, if I want to remove this negative, we get the what? The reciprocal of the rational numbers. So what will be the reciprocal of that? It will be 3 to the power 3 divided by 2 to the power 3. Now, this time is a positive power now because we have got the reciprocal of this. Are you together, members?
Yes, teacher.
So once you have got the reciprocal, the power will change. The power will change. If it's positive, it will change negative. If it's negative, it will change
positive.
Positive. Good. So now after that, now you can bring in, we shall have now 3 to the power 3 times a third, divide by 2 to the power 3 times a third. This will cancel that, this will cancel that. Then we remain with 3 over what? 3 over
2.
Have you seen? Are they the same? Are they the same? When you look at the previous example we have done, are they the same? When the power was positive, we got 2 2 over 3. But when the power is negative, we got 3 over
2.
So it's just a matter of getting the reciprocal of the other one. That's how that power is applied. Have you seen how it works?
Yes.
Good.
Yes.
Very good. Very good. Is there any question so far? Any questions so far? We have 3 minutes and then we go for a break. Any questions so far?
No.
No. There are no questions, eh?
Yes.
Okay. Now, work out for me this. Work out for me this. Example. Simplify. Simplify. We have 81 over 64 to the power negative 3 out of 2. Okay? Work out for me that. Work out for me that. So what are we going to do? We have to, let's remember, let's be faster. Solution. We have 81 over 64 to the power negative 2. I mean 3 over 2. I said, now when you look at the power here is what? Negative, right?
Yes.
So if I want to make the power positive, what should I do? If I want to make the power positive, what should I do?
You get the
You get that.
Find the reciprocal.
So the reciprocal is it? 64 over
64,
81.
81.
So 2 out of, I mean 3 out of
2.
3 out of 2. Then you said bad. 64 is the same as 2 to the power. We can put to any power. Okay? Or
Yes.
someone can use
8 power 2.
8 squared. I think that. Yes, but it's always good to make it to the lowest power, the lowest possible base. Okay? So for this case, we are going to take 2. We are going to take 2. Then 81 is the same as 3 to the power
4.
3 to the power 4. So after that, put it back. So we shall say 64 out of 81, 3 out of 2 is equals to, so we shall have 2 to the power 6 out of 3 to the power 4, but the power is 3 out of 2. What next after that? We distribute the what? The powers. We shall have 2 to the power 6 times 3 over 2 divided by 3 to the power 4 and 3 over 2. Okay? By 2, 1, by 2, 3. By 2, 1, by 2, 2.
2.
So we shall have 2 to the power 3 times 3,
9.
9.
9.
Divided by 3, 2 times 3, we get
4.
6.
we get what? We get 6. Right? I think that.
Yes. Yes.
What do we do for